This video will talk about operations, the symbols that represent them, and then the order that we have to do the operations in. So, we mentioned in a prior video different ways to write multiplication. You can use a traditional x times symbol, though we get away from that in algebra. The dot works. Parentheses also represent multiplication if there's just a single number in the parentheses and if they're next to something. Parentheses can mean different things. For example, 2 parentheses, 4 parentheses, like that would mean 2 times 4. You could also write it like this. That also means 2 times 4 is equal to 8. For division, this is a traditional division symbol, but so is a fraction bar. We can write 30 divided by 5, or we can write 30 divided by 5. Those both represent divisions. We also have some other symbols like exponents, right? We talked about exponents in a prior video. And we're going to talk a little bit here about grouping symbols like parentheses and brackets. In fact, that's what I'm going to talk about next. Grouping symbols. Sometimes we want to, we have a big long process of problems, a bunch of numbers that we need to do stuff to. We call those operations. But we need to group a certain part of the problem. And so we might use parentheses to do 3 plus 5, and then there's other stuff to do around it. Sometimes we use brackets, which are the same thing as parentheses, but we often use them when there would be parentheses inside. 3 plus 5, and then here, and then we might say divided by 2, and then outside of the bracket there could be more stuff. So parentheses and brackets are different types of grouping symbols. Those fraction bars also are grouping symbols. We'll get into that in a minute. They group all the stuff on top together and all the stuff on the bottom together without showing the parentheses. So those are symbols that can group things together. There are more, but that's all we're going to focus on right now. And so you've talked about the order of operations before. Order of operations. And you've probably heard, please excuse my dear Aunt Sally, or PEMDAS, right? And you may or may not remember what those stand for. And I'm just going to say, I don't like PEMDAS or Aunt Sally very much because it really messes people up. I'm going to try to give you a way that it has the same operations, but just with a different acronym. And it's this. Rather than 6 operations, we're going to really think about it as 4. G-E-M-A. Let's call it GEMA. GEMA. So the G stands for grouping symbols, which is what I just talked about. Things that are grouped together, you have to do that stuff first. This is like a checklist where you go from top to bottom. Next come exponents. And then the M stands for multiplicative operations. Multiplicative operations. When you did PEMDAS, it was M and D, and those stand for multiply, divide. People get confused because they would think, I've got to multiply before I divide because M comes before D. But that's not actually how it's done. Multiplicative operations are multiplication and division. They're inverses of each other, right? 2 times 4 is 8. 8 divided by 4 equals 2. They sort of undo each other, right? They go back and forth between the same groups of 3 numbers. And then the A in GEMA, G-E-M-A, G-E-M, the A is additive operations. Additive operations. Now, I bet you can guess what those are. So those would be addition and subtraction. It's just like the multiplicative ones, right? addition and subtraction sort of undo each other. They're inverse operations. 4 plus 3 equals 7. 7 minus 4 equals 3. You get back to where you start when you do the other operation. So we do these from left to right when we see a problem, left to right. So we would do all the multiplicative operations from left to right, whichever one comes first, and then all the additive operations from left to right, whichever one comes first. Here are a couple problems. I'm going to give you one right off the bat that people get confused about. 8 minus 4, parentheses, 10 minus 8. So I'm going to highlight some of these. So what you're going to see are 3 different operations. We have subtraction. Whoops. We have, sorry, I meant to get my highlighter. We have subtraction. You see another subtraction in here. But remember, when a number is touching parentheses, even though we don't see a symbol right here, that means multiplication. So we've got 3 operations. I'm going to go back and write G, E, M, A. Are any of them grouping operations? Yes, this one is. 10 minus 8 is in parentheses, so we have to do that first. That's 2. Always write the rest of the problem down. 10 minus 4, and bring down the parentheses. Do we have any more grouping symbols? You might be thinking 2 is in parentheses, so we must do something with that next. Well, 2 is just a single number in parentheses. It's not being grouped anymore because there's nothing to do inside the parentheses. So we are done with grouping symbols. Then we go to exponents. There are no exponents in this problem, so we're done. Then we look at the multiplicative operations. Is there any multiplication or division? And there is. There's multiplication right here. You might be lured in trying to do 8 minus 4 here, but really you have to do this multiplication first. 4 minus 2 is 8. Bring down the 8 and the minus. Now we just have an additive operation left. 8 minus 8 is 0. So the value of that is 0. Next. And as I put up these next ones, pause the video, come back, and then watch the explanation. So here we have a bracket, 5 plus 3, parentheses, 2 minus 1, parentheses, bracket, and then an exponent of 2. And your instruction on these, the command would be evaluate. Evaluate. So pause, work through it, and then come back and watch the video. What I see here are operations of addition, multiplication, right? The 3 is touching the parenthesis, minus. We've got a grouping symbol which has that minus. We've got a big grouping symbol which has all this stuff. And then we've got an exponent. So when you have multiple grouping symbols, you work from the inside out. So we're going to start with this. Just do one thing at a time. 5 plus 3, bracket, bracket, exponent. I'm not touching any of that stuff. I'm only doing what's inside this parentheses. 2 minus 1 is 1. Step 1, done. Now we keep working inside the bracket. We have to keep working inside the bracket until we have a single number. We can't do anything with this exponent until we've done the whole bracket. So now we have addition and multiplication. We're going to do this multiplication right here next. 3 times 1. So we have 5 plus 3. Bracket, exponent. Now we can finish off the bracket. 5 plus 3 is 8. We can do that addition right here. And then 8 with an exponent of 2 is equal to 64. So let me scroll down here a little bit further. And let's look at a couple more. All right. So let's do one with a fraction. Evaluate. There's your word, evaluate. 1,000 over, parentheses, 0.05, parentheses, parentheses, 4. So the reason I'm putting this one up is because this is a commonly missed type of problem, especially if you're using a calculator to do some of the work. In fact, I'm going to pull up a calculator and show you what this looks like. So The way that a lot of people would type this into a calculator would look at this and say, well, I've got 1,000 on the top and then divided by 0.05 times 4. So you would type it in your calculator as, I'm going to tell you, this is wrong. You would type it in as 1,000 divided by, again, this is wrong, 0.05 times 4. And you get 80,000. That's not right. And if you look at what's up here in my window, my calculator window, look at what it did. 1,000 divided by 0.05 times 4. It took and divided by 0.05 and then took that answer times 4. But that's not how this problem was laid out. This stuff down here is technically grouped together, even though you don't necessarily see it. It's grouped together. What you really need to do is leave 1,000 on the top over and do this thing first. 0.05 times 4 is 0.2. And then divide 1,000 by 0.2. And that is divided by 0.2. 5,000. Definitely not 80,000 that we had by doing it the other way. Equals 5,000. This particular problem type here is going to come up later in the class when we start working with interest and calculating interest. You'll often have calculations that look like this. A couple more. So I need to talk about exponents a little bit because something comes up with exponents that often gets really misunderstood. People like to apply the exponent to the wrong thing. So I'm going to put two problems up here at the same time. The first one is 4 times 3 to the second power, 4 times 3 with an exponent of 2. And then the other one is in parentheses, 4 times 3 in parentheses with an exponent of 2 out there. I'm going to write it sort of off to the side, actually down here, because this is a big thing to remember. Write this down. It's so important. Exponents only apply to what is directly beneath them. Exponents only apply to what is directly beneath them. So, in the first problem, and these are two different problems. In this first one, what is directly beneath this exponent? Right here. It's the 3. So, in this problem, the 3 gets, call it squared. It gets the second power. In this problem, what's directly beneath the exponent? It's the parenthesis. So we're going to apply this exponent not to the 3, but to the whole result of the parenthesis. In this one, we do the exponent first. In this one, we do the grouping symbol first. So the first one looks like 4 times 9. All right, 3 squared, we say 3 to the second power. 3 times 3 is 9, and 4 times 9 is equal to 36. In this one, we have to do the grouping symbol first. 4 times 3 is 12. And now the exponent applies to this number. 12 squared is 144. Okay, so keep in mind, when you're doing an exponent problem, the exponent only applies to the thing that is directly beneath it. It might be a number, it might be a parenthesis, right? So pay really close attention to